Hello my friends, welcome back to the Innovation Lab. So in this video I wanted to show you the design and build of these lithium phosphate battery packs that I have shown in a few of my videos, and I am also intending to use this battery pack to for my solar generator project, which is still ongoing. And so these batteries were designed from scratch here at the Innovation Lab, and so we designed it here and used some in-house technology like 3D printing to build the actually print the enclosure. So I wanted to show, I know that not everybody out there has access to 3D printers and things that I use here, but what I wanted to show here, the purpose of this video is to show, because my aim is to make a video for everything that we build in the Innovation Lab, and also to kind of show people what is obtainable, what is possible. So again, I know not everybody has 3D printers, not everybody has access to every component and parts that I used, but yeah, I just wanted to share this build and show everybody that is supporting the Innovation Lab what is possible and what we're building, what we are up to. So yeah, and before we continue, I wanted to take this opportunity to thank everybody that has been supporting the Innovation Lab, and all my subscribers, and everybody that's watching our video and leaving good comments and feedback. So I just want to thank you guys. I really appreciate it. So doing what we do requires a lot of support and inspiration, and I really appreciate it. So back to the batteries. So a while ago I ran into these lithium phosphate cells, and I decided to give them a try. So these are called 32700 cell lithium phosphate batteries. So I like them because they are quite big and they promise a whole lot of capacity. So if you look at it here, this here is 3.2 volts, so it's rated for 3.2 volts, 6,000 milliampere hours. So that's a lot of capacity. So what motivated me to give this a try is the fact that you can put a few of them together and have all the power that you need, instead of like if you are to use the small 18650 battery cells, you will be welding a lot of batteries, and that would take a long time. So yeah, so that's what's inside these guys, and so I'm going to show the steps that I used to build it and all the components that went into building it. Also, I know some people would say, you know, why didn't you just build one single 24 volt pack? So the reason for that is I wanted to make this design adaptable. I wanted to make it such that I can repurpose these batteries for like a 12 volt application, and if I do need a 24 volt application, I can easily connect them in series. I made a cable here that I can use to connect them in series, or if I have a need to stack them depending on what area of space I'm working with, so I can just stack them this way, and there you have it. So if I connect across, I will have 24 volts. So that's the plan, and that was why I made it this way. So yeah, so again, let's get to show what these batteries can do, and then we get to the actual building of the batteries. All right. Oh yeah, so just a quick demonstration of what these batteries can do. So I'm gonna use this setup, which is the same setup that I used to test this inverter in my last video. So if you want, you can check out that video as well. So these batteries can actually drive at 24 volts, can actually easily drive a 1000 watt load on this inverter. So with no hiccups, no issues at all. So as you know, even as I run it, you're going to see how much current these guys are gonna be able to pull going into the inverter right before we go into the build. So if I turn on the inverter, so what you're looking at there is almost like a 1000 watt load. You can see it's driving it so peacefully, no issues at all, no overheating, nothing. So if we look closer to the power meter, so you see it's drawing about almost 45 amps. So yeah, so these packs here are able to supply 45 amps at 24 volts to this power inverter to drive this. This is almost a 1000 watt load on the output. Also, one thing that I forgot to mention was that actually these battery packs were my motivation for building the spot welder that I've shown in a separate video. So I had a concern that the regular spot welder is mostly designed for 18650 batteries. I have not used them for this type of huge cell or cells before. So this battery pack, the design of this battery pack actually was what inspired the build of the smart spot welder that I have now, that I showed in the video. So yeah, so I just wanted to mention that because it's something that is really important to me. So the design starts with the 3D modeling of the solar generator that I have talked about many videos. So as you can see here, you see the LiPo packs down in the model. So yeah, so I've actually had people ask me, if you're interested in this, of how I'm gonna be able to fit a 400 watt solar panel into this design. So what I say to them is make sure you subscribe so you get to find out. So yeah, so the model of the battery came from that design. So now what we're looking at here is the 3D modeling and design of the battery holder, the housing unit, and the top cover of the housing unit. So and this shows the overall view of what it's supposed to look like after everything is built. Like I mentioned, so I had to use 3D print all the housing and enclosure and everything, and because the enclosure was bigger than my 3D printer can handle, so I had to like print it in half and kind of glue them together after printing. So the print bed of my 3D printer was a little bit smaller than the actual housing, enclosure. So what you're seeing here is the good thing about some of the materials that I used to print. These materials are printed out of PLA. So the good thing is that you can actually sand them down like you would do with a regular plywood material. So to make them, to get them as smooth as you want them before you paint them. So yeah, so this is the painting of the enclosure, and I'm using a special kind of paint called hammered. It kind of gives it the rough, rugged look, and yeah, I like it because it also dries fast and very rigid. It doesn't scratch. So yeah, so I'm making sure I capture all the angles and all the sides without missing anything. So it's quite fun to actually go through this process. So yeah, so and this shows both enclosures and top covers for the batteries. So here will be the beginning of the assembly process, which is quite simple. Now we organize the battery cells. Five in parallel and 4 in series to give us the each 12 volt 30 ampere hour pack. So and now putting them together, quite fun and interesting to do. So there you have it. So we have the first pack and we have the second pack. So placing them side by side to each other. So this is the first 12 volts, second 12 volts, and both of them in series will give us the 24 volts that we need. So now this section basically shows the tabbing process and the spot welding process. So again, as I mentioned earlier, I used the smart spot welder that I built, basically that was inspired by these battery packs. That's what I'm using here, with set controlled weld pulses that will deliver the perfect weld without to make sure that I have a good weld. Yeah, so as you can see it, the weld looks really nice. There was a little bit of a burn in the welding, but that's okay. I mean, given the fact that, you know, the spot welder was not, I would say, not professionally built. So yeah, so it still gave us a very clean weld. And I did a pull test for before of the setting before getting to use them on the battery, just to make sure that the welding is really good. So yeah, as you can see here, it's quite welded nicely, and I made sure I gave each battery tab like 6 welds, just to be sure, you know, they will capture the welding process, as you know, give me good connections on the battery tabs. So the next thing I'm doing here is to actually solder the connecting tabs between, you know, going from battery negative to positive and negative and that. So as you can see here, that is basically what this process is. So the steps you see from here on shows the BMS installation, connector installation, and actually installing the battery into the enclosure itself. So everything, I believe, is very straightforward. So as you watch the video, you can get to see how I'm doing the build. All right, I hope you have fun watching this until we get to the end. So the next thing we're going to do will be to install the battery BMS, which is the BMS stands for Battery Management System. So this device basically makes sure that the lithium phosphate group of cells does not or will not overcharge or over discharge. So to make the connections, as you can see on the unit, so you have power negative, battery negative, then we have the 5 sense lines, so they are color coded. So we have black, white, blue, yellow, and red. So, and each one represents the voltage levels that the BMS is going to be monitoring. So as you can see in the schematic, so the schematic is quite simple. So if you are to use this BMS, just follow this schematic. So the black wire, it goes to the battery negative. The white wire goes to the basically the 3 volts, monitors the 3 volt level. The blue wire monitors the 6 volts or 6.4 volt level. Yellow monitors the 9.6 volt level. And you have lastly the red wire monitors the 12 volt level. So yeah, that's how the connection should be made. It's very straightforward, and there's a little bit of soldering that you have to do to solder the battery tabs, because those are going to be conducting high current. So you want to make sure you do a very good soldering on it to hold it in place. And again, I'm using the silicone wire, which is easier to work with and is quite very flexible and can handle a lot of current. So yeah, so this is, I just wanted to kind of jump in here and explain what this process or this step looks like. So you have to be very careful to make sure you do it right. If not, you could damage your cells, or this device will not perform the function that it is supposed to perform. So make sure you do it well. Alright, so what I'm doing at this stage is to install some additional insulation because we have to think about safety every time we're building something like this. So because these batteries are, as I mentioned before, these are very high power density and energy density batteries. So you want to make sure that you don't have any exposed battery tabs. So to do this, I am using I'm using high temperature Kapton tapes to be able to do that. So yeah, so now we're looking at the finished enclosure. As you can see, looking at the enclosure, there is some lines that you can see there, and as I mentioned earlier, the reason for that is this design ended up being too big for my print bed, and I had to kind of fragment the print there to be able to get it to print and basically glued it together before doing some painting and sanding, as I showed earlier. So yeah, with proper dimensioning, the battery was able to go in nice and neat, no issues at all. And having to use the high current silicon cables were very useful because they are very flexible and very easy to work with. So yeah, so the next thing that we're going to install at this stage will be the XT60 connectors. These are very impressive connectors. They're very compact and can handle a lot of current. I believe these are rated for 60 amps per pin. Yeah, so and what I'm doing here is kind of doing a pull test to make sure that they have I'm going to be getting a very firm connection as when I attach them to my power cables. So again, safety is very important. So I made sure that if you're going to do this, you have to make sure that you properly insulate everything. So what I'm using here is just a simple electrical tape to make sure that everything is very well covered, and I'm not gonna have anything touching on the inside. So yeah, and there you have it. So after the installation, it will be now time to basically wrap up the build. All right, my friends, there you have it. So I must say that I am quite impressed with this design and build. It did turn out to be really quite impressive, at least to me. So I'm not going to try to do more, add more testing to this video because I've already tested these batteries a lot in my previous videos and also in the beginning of this video. So I'm very satisfied with the outcome. So, and also as you can see here, I'm using the XT60 connector for the output positive and negative. Those connectors were originally rated for 60 amps per pin. So what I've done here is to use 2 redundant pins, so that way each connector can handle up to 120 amps of current going through them. And the cables that I'm using are silicone cables. They are thin cables they can handle also, even though they are flexible, but they can also handle a lot of current. So so yeah, so this is quite impressive. I am happy with the build, and if you would like to see the outcome of the solar generator project where I'm going to use these batteries, be sure to subscribe to the Innovation Lab so you get notified. And once as we release that video in the future, and also there's going to be more components that's going to go into the overall project that I'm going to be showing in the future, like solar panels and the actual I've not actually tested the solar charger that's going to go with the unit. So if you like to see all of those, subscribe to our channel so you will get notified as we release those videos. Alright my friends, we've come to the end of this video, and I hope you had some fun. I hope you got some entertainment out of it, and if you did, don't forget to leave us a thumbs up, subscribe to our channel, and share the video with your friends and family. And yeah, so thanks again for watching, and see you in the next video.